to work on the worksheet for section 3.2, graphing polynomial functions. And if you look here, I have the answer key in front of me instead of just the worksheet, so we can kind of add some notes here. Okay, so what we're going to do is we're going to use these steps to actually graph the polynomial function that's listed here. The polynomial function is f of x is equal to 2x cubed plus x squared minus 8x minus 4. The first step we're asked to find is the end behavior by looking at the leading term. Okay, so here's our leading term. We can tell the leading coefficient is 2, which is positive, and the exponent of the leading term is odd. So the end behavior should go up to the right and down to the left. And that's listed right here, of course. Okay, now let's go to step 2. Step 2 says find the zeros of the polynomial function by saying f of x equal to 0. So what we did here is I set f of x equal to 0. Let me just move down a little bit here. There we go. Okay. Okay, so here's f of x. I set it equal to 0, and I solved below here. And then we got the zeros to be -2, -1/2, and 2. Those are my 3 zeros, or my 3 x-intercepts. I will plot them a little bit later. Okay, let's go to step 3 now. Step 3 says use the x-intercepts, or the zeros, to divide the x-axis into intervals and choose test points in each interval to determine the sign of the function. In other words, if the sign is positive, it will be above the x-axis. If the sign is negative, it will be below the x-axis. Okay, so let's set up this interval first. So we're going to look at this x-axis and divide it in intervals. Here's my x-axis. And I'm going to label my 3 zeros on this x-axis. 1 0 is -2. Another 0 is -1/2. And my third 0 is 2. Okay, so those are my 3 zeros. Okay, so what these 3 zeros do is they actually divide the the x-axis into 4 different intervals. So let's label those intervals. The first interval is this interval over here, which is -∞ to -2. And that's labeled right here. The next interval is between this part and this part, which is -2 to -1/2, which is right here. And then we have between -1/2 and 2. And then finally, everything over here, which is 2 to infinity. Okay, so that's the first part. We created the intervals. Now what we're going to do is we're going to pick test points. Let me erase so I have a little bit more room first. Okay, so let's pick some test points. The first thing we want to do is we want to pick a point between -∞ and -2. So we want to pick something over here. So if you look at this table, they decided to pick -3. -3 would be like right there. That's your test point. Then what they did was they plugged in -3 into the function. So in other words, they found f of -3, plugged in -3 for x, which I'll do here. Oops, that's a plus right there. Okay, so if you look at this, we plugged in -3 for x, and if we simplify that, it should be equal to -25. Okay. Since the negative number, they put a little negative sign here, and since the negative number, what that basically means is the graph will be below the x-axis on this range. So over here, it will be below the x-axis. The graph will be down here somewhere. Okay, then they picked a test point in the next range. The next range is between -2 and -1/2. So that's between -2 and -1/2. So they chose -1. Again, they plugged in -1 into our function, and they got the answer to be 3. That's a positive number. So that means it's going to be above the axis between -2 and -1/2. Okay, I'll let you read the rest on your own before I go to the next part now. Okay, now we're going to do step 4. Step 4 is you find the y-intercept by finding f of 0. They did that actually right here. F of 0 is equal to -4. So there's my y-intercept, 0, -4. Now we'll go to step 5. Step 5 says, if necessary, find additional points so that we can get a rough idea of our graph. Now we actually have a couple order pairs already, so this would be one order pair, -3, -25. This would be another order pair. We have order pairs listed here, but they came up with a couple more right here. So again, they plugged this in for x and they got this value for y. Okay, let's move down the slide here to go to the next part. Okay, now let's go to part 6, the step part 6. As a partial check, use the facts that the graph has at most n x-intercepts. Okay, so again, here's our function that's written above there. N is 3. So it should have at most 3 x-intercepts. And if you look here, you actually do have 3 x-intercepts. And it should have at most n minus 1, which is n minus 1 is 3 minus 1 equals 2. It should have at most 2 turning points. Turning points are our max and our mins. Okay, so what I'm going to do next is I'm actually going to find the max and the mins using our graphing calculator. If you take a calculus class, you learn more how to do that algebraically, but for right now, we're going to just show you how to find it in a graphing calculator. Okay, so let me pull up my graphing calculator here. Okay, I want to go ahead and put my function in for y equals 2. I have that in already. You want to do that as well. And for my window, I want the same window as this graph paper here. So I went from I actually went from -5 instead of, -5 to 5 for x. And I went from -10 to 20 for my y values. And I go ahead and graph it. If you look at this, there's one relative max. I'm going to mark it. There's one relative max. And there's one relative min, so there's 2 turning points. So we're going to actually find both of those using our graphing calculator. Okay, let's find the max first. The way we find the max is we're going to use our calc key right here. We're going to hit second, calc, max. And just like your zeros, you want to go to the left of that max, hit enter, go to the right of that max, hit enter. At the guess, you hit enter, and we get the maximum to be the coordinates of -1.333 if you round, 3.7. Okay, now let's find the relative min. So now we're going to find this min right here. So we do the same thing, except for instead of max, we're going to pick min. We're going to go second, calc, min is number 3. And then I'm going to go to the left of this min. So I'm going to arrow over, hit enter. Go to the right. Right bound means go to the right. I guess I hit enter again, and I get that minimum to be 1, 9. That's my minimum. Okay, let's take this off here for right now. Okay, so now we have enough information to graph this particular graph. So I'm going to go ahead and plot the points here and finish up. Okay, the first bit of information is our x-intercepts, -2, -1/2, and 2. That would be the first bit of information. The next bit of information we can't see, but it talks about the end behavior. Remember, our end behavior says it goes up to the right and it goes down to the left. So that'd be the next bit of information. The next thing I would plot is my y-intercept. So I'm not going in any order. I'm just putting this in here as the orders I would go in. There's my y-intercept. Then I would go ahead and plot my max and my min, which I had to find with my calculator. My max is -1.3, 3.7, right there. And then my min is 1, -9. Okay. And then you want to plot a few extra points. So you can either use the points right here or the points right here. Just enough points that makes you comfortable with the graph. I already have it on there, so I'll just complete it here. Okay, and then now we're done. We're done graphing this particular polynomial function.